Welcome to Lab Coat Optional from Arizona State University, the show where advanced research meets everyday curiosity. I'm your host, Pete Zrioka, and today I'm joined by Dr. J. Bhattacharya, the director of the National Institutes of Health, and the first guest I've had whose job required Senate confirmation. So no pressure there. Dr. Bhattacharya earned both a medical degree and a PhD in economics. He's a researcher and health economist who held a tenured professorship at Stanford University before taking the helm of the NIH in March 2025. He's also currently the acting director of the Centers for Disease Control and Prevention. Busy guy. The NIH provides a massive amount of funding for biomedical research. The funding and discoveries it's enabled have improved countless lives over time, from driving down lung cancer rates in the United States by linking it to tobacco use, to advancing antiretroviral therapies that greatly extend the life expectancy of people living with HIV. In this episode, we talk about what's on the horizon for NIH, building trust with tribal communities, his push for more replication research, board games, and his advice for young researchers. So stay tuned to hear all of this and more. Dr. Bhattacharya, Director Bhattacharya, welcome to the show.
Nice to be here. You can call me Jay.
Jay it is. Okay. I just wanted to set the table for everyone. For those in our audience who might not be familiar with the National Institutes of Health, can you tell us what the agency does and about your role as the director?
Sure. The National Institute of Health, it's the single largest funder of biomedical research in the world, public funder of biomedical research in the world. The goal and the mission of the NIH is to fund research, biomedical research, that improves the health and longevity of the population. And so it's been around for more than 100 years. It's a big institute, actually. It's funded at about $50 billion this past year. As the director of the NIH, I help set priorities for the institute. I oversee its operations. And I work with folks both inside and outside the institute to make sure that its mission is operating, is like actually happening.
So you mentioned the history of the NIH. It's been around for almost 100 years. Could you give us a quick history lesson and tell us about some of maybe the historical NIH funded advances that have really benefited human health?
Sure. So it started as like a small laboratory. And it really took off during the New Deal era. I'm sitting right now in the NIH director's office in Building 1, which is located in Bethesda, Maryland. Mm-hmm. Outside, there's a plaque of FDR commissioning this building. Like he gives a big speech in 1936, 7, I forget exactly. Especially after World War II, it became the hub of so much investments that the government has made in research in biomedicine. It's almost impossible to find an area of biomedicine where NIH research hasn't played a fundamental role in shaping what we do. Almost every single treatment, drug, sort of medical sort of procedure that people now undergo for managing their health, it had some investment by the NIH at its root.
That's incredible.
And so it's really a humbling position because to be in, where I think I'm the 18th director of the National Institute of Health, and it's I think like 85% of all the money that public institutions put into biomedical research, including foundations, including other countries, 85% of that money is NIH money. It is literally the single biggest funder of biomedical research in the world. That not apart from drug companies.
So the NIH has touched almost everyone's lives in the United States over its history. Looking ahead, I'm kind of curious as to where you see some research opportunities on the horizon to continue to benefit human health.
Well, the NIH is it's supposed to address the chronic the health problems of the country. And if you look at the health problems of the country, they're so considerable, right? So this is the little known fact, but it's unfortunately true. Since 2010, the U.S. has had basically flatline life expectancy. the life expectancy of the population today versus 2010 is roughly the same. This is shocking because for generations before that, every year, life expectancy would continue to go up and up and up and up. Since 2010, it's flatlined. And of course, there was a big collapse during COVID.
Sure.
There's huge chronic disease problems in this country, from childhood to old age, right? So the autism, 1 in 31 kids are autistic. That's much higher than it was once before. There's childhood diabetes. There's problems of youth suicide. There's problems of once you go get a little older, you have problems of heart disease. You have problems of type 2 diabetes. You have cancer.
Mm-hmm.
You have even once you're even a little older, you get Parkinson's disease, Alzheimer's disease, Down syndrome. There's a whole host of medical conditions that need real research done to make the lives of people better. And we have investments in all of those areas. Add more. It's actually amazing. The most fun part of my job is I get to walk around and I talk with a scientist and they tell me some new idea that just blows my mind. And they're all focused on really using science to make the lives of people better.
So you mentioned cancer and Alzheimer's in there, and I'm not. You're probably better accustomed to cite the numbers to me, but I think there's two of the top areas of NIH funding. Where do you see strategies or opportunities to address these chronic diseases other than funding?
Yeah, I mean, the question is like, what do you fund, right? Mm-hmm. That's really the key. Like, so the money, of course, is important, but even more important is how do you decide which project? Because the NIH gets about 100,000 applications a year with ideas. And even with such a big budget, we don't have anywhere near the budget to fund all 100,000 ideas. So we have a system to select the best ideas, where other scientists sort of chip in and say, "Oh, these are good ideas, and these are probably maybe good, but they're less good." And every year, tens of thousands of scientists give us advice about that. In Alzheimer's disease, for instance, it's such a disabling condition, and it's also something that a lot of people are scared about because they think, well, what if I stop remembering my loved ones' names or faces? I mean, you can imagine the fear that comes with that. The investments we made in Alzheimer's disease have put us in a place where we actually might be able to have real breakthroughs that can help prevent Alzheimer's disease. There was just a recent paper, for instance, from a study that started 20 years ago, where we're tracking people from for the last 20 some years, where what we found is that simple puzzles that you do every day, sort of things that you use your brain every day, actually has a good possibility of extending the time before you get Alzheimer's, delaying the onset of Alzheimer's. This is a project I'd love to see supported. There's some great research that a old shingles vaccine, no longer on the market actually, very safe. Didn't like I had it when it was called Zostavax. Okay. It's no longer on the market because it turned out to be not that great for shingles. It didn't prevent you. It didn't cause many side effects, but also didn't prevent shingles very well. But that old shingles vaccine actually reduces the risk of developing Alzheimer's disease. I mean, it's stunning, right? So you can have these like simple ideas that can solve potentially some of the most deadly problems. Cancer, it's incredible to watch when I was a medical student in the 1990s, the idea that you could use your own immune system or reprogram it to attack cancer cells was fantasy. Yeah. Like people thought it was not possible to do. Now, some of the most promising cancer therapies no longer involve deadly chemotherapy or radiation treatment, but rather reprogramming your own immune system to attack cancer cells selectively without causing all the damage to the rest of your cells in your body. We stand on the brink of like just tremendous advances. It's very, very exciting time to be in biosciences. And we just need to address the chronic health problems of the country, reverse the flatlining life expectancy. And I think the NIH is the key institution to do that with.
You mentioned the old shingles vaccine, which I've had shingles before. I don't recommend it.
That's no fun.
No, it was terrible. But you remember you mentioned the old shingles vaccine, which could potentially be a good treatment for Alzheimer's, which is a good example of like repositioning or repurposing drugs, which I know is a focus of the NIH. How do you aim to augment those efforts? And then what are the kind of the roadblocks to finding drugs that could possibly help other ailments and that they were designed for?
Yeah. So let me just I have a PhD in economics in addition to my MD. So let me just put my economics hat on for just a second.
Yeah.
If you think about why more drugs, we have a system where we approve a drug for something,
Mm-hmm.
and often that drug has other uses that we don't know about. Like there's lots of examples of Viagra is a good example of this.
Yep. It was a heart
Very
medication,
famous
right?
example of it, right? So it was a heart drug originally.
Yeah.
Then they found a funny side effect in the trials, which then
Yep.
So the thing is once a drug is off patent, there's no economic entity, no drug company that has any real incentive to see if it's useful for other things, and often it is.
Yeah.
Now you have to do a rigorous science to check if it is or isn't. But the one of the roles that the NIH plays is to solve that market failure,
Mm-hmm.
to make it so that there's investigation into the off-label use or off-label use of off-patent drugs, because very often you end up with new uses that solve problems for people, and because it's off-patent, it's relatively inexpensive.
Yeah.
Potentially, right? The vaccines are not. That's not the patents isn't the key thing. It's like you have a marketing incentive. So a drug that's no longer a vaccine that's no longer on the market because it doesn't work for shingles, there's going to have no incentive to check whether it works for Alzheimer's.
Mm-hmm.
That's where the NIH steps in and says, look, we're not trying to make money off of this. We're trying to develop scientific advances that solve health problems, that fundamental health problems that people have. And other people make money off of this. We create economic growth as a result of improved productivity. And of course we are sort of the impetus for developing massive industries actually with these investments that benefit taxpayers in many other ways. But it's fundamentally what we're about is taking scientific method and applying it to things that solve people's problems.
Another thing you mentioned in terms of priorities for the NIH was autism research. I was wondering if you could tell me a little bit more about where those efforts are and what opportunities you see for addressing that. The
CDC had an estimate that 1 in 33 kids today have some kind of autism. Whereas just a few decades ago, the diagnosis rate was about 1 in 10,000. There's been a huge increase in autism diagnoses. And autism as a diagnosis is a complicated thing. You have a very, very wide range of sort of phenotypes that come out of an autism diagnosis. There's some people with autism diagnosis who are severely disabled, nonverbal, potentially prone to self-harm, with repetitive movements, and you have a child who has that kind of diagnosis. And it fundamentally transforms the life of the family. Makes it so much, and with the real need for involvement of help to help find ways to make the child better. On the other range of the spectrum are kids who have maybe they're a little socially awkward. There may be some other things about them, but they're really well integrated into the community, fully functional. And so there's a very wide range of phenotypes in autism. As well, it seems likely to me. Now, I don't know the cause of autism. As a researcher, I've looked, and there's a large number of hypotheses. But I will say is that it looks to me like a condition that's likely to have multiple different pathways that lead to the multiple different phenotypes. In other words, there's not going to be a single cause of autism. And the range of hypotheses I've seen include, genetic predisposition, that you have some certain genetic patterns that make it more likely, environmental exposures from certain things, as well as the interactions between genes and environments, where certain people with certain kind of genetic predisposition, when they're exposed to a certain environmental exposure, are more likely to have kids. There are hypotheses like based on just facts, like when children are born to older parents, they're more likely to be autistic. There's a whole range of sort of scientific hypotheses I've seen. And yet I don't know what the cause of autism is. And so we've been investing in something called the Autism Data Science Initiative. The NIH has lots of investments in trying to solve this problem. But when I got in, one of the first things I did is I invested in a program called the Autism Data Science Initiative, where we funded, I think, 13 scientific teams with like replication built in to answer this question. What are the biological roots of autism? The etiology of autism. I'm hoping that these kinds of investments will lead to answers for parents who have autistic children, better treatments, better ways to manage, better ways to potentially prevent, depending on what the result turns out to be. I wanted to whenever people talk about autism, people's hackles go up because well, what if vaccines cause autism or whatever, right? I wanted to sort of lower the temperature and just have science lead the way on this. And I'm anticipating learning a lot more and starting to have answers for families who face this.
Thank you for sharing your perspective on that. Earlier, you talked about one of the most fun things about your job is talking to all these different scientists with these great ideas they have. I was kind of wondering about how, when you're looking to invest in certain research, how do you balance investment in kind of basic scientific research versus something that may be a little bit more outside of the box or kind of a moonshot idea, but also have the potential to be very transformative?
Yeah. So, I mean, on like just at one level, about half of our portfolio is basic science. That means people sitting in the lab doing experiments, and half of it is applied science, like clinical trials, for instance. Okay. At another level, and this is a really, really important point about what we do and some of the challenges we face. If I wanted to invest in a project that I knew would succeed, and then I could brag, well, look, it succeeded. What you would end up with is a very, very small incremental advance in our knowledge. Something that doesn't have of course, it's maybe important, but it doesn't have the potential to make a big leap to solve type 2 diabetes, for instance, right? And so you have to create incentives and systems. When you pick the 100,000 applications we get, you have to pick among them, so that people don't the portfolio, the people who pick this portfolio of projects, they're all scientists. That you allow them to take intellectual risks. It's hard because when scientists look at a proposed project, and suppose it's a brand new idea that no one's really thought of before, our first instinct as scientists is always to say, well, there's no way that could work. Especially if it's someone else's idea. Yeah. Right. If you have your own idea, of course, you may fall in love with it. But it may be hard to convince your fellow scientists that it's worth investing in this idea that's so different from everybody else's ideas. And yet, in science, that's the only way science really makes big leaps forward. And so, like the challenge has been for a long time at the NIH that the research is focused on on projects that were certain to succeed, but would only produce incremental gains. Sure. There's another sister agency of ours called ARPA-H. It was founded just a few years back. And it was partly funded because there was concerns that the NIH wasn't investing ideas that were at the bleeding edge. Right. It's a much smaller agency, but it's an important agency for that reason. At the same time, I believe fundamentally the NIH has an obligation, and in its history, its past history of 100 some years, it's actually been it actually has as in its DNA this investment in very, very challenging, potentially high reward ideas that may or may not work out. So I've been working on allowing the folks who decide these research portfolios to give them strong incentives and essentially the blessing to try ideas that may not necessarily work out, but if they do work out, they would make big advances that could solve people's health problems. Basically, the key thing is if you're in charge of deciding what grants to put, what I'm going to tell you is like, look, if you fund a portfolio of 50 projects and 49 of them fail, and the 50th cures type 2 diabetes, well, as far as I'm concerned, you've done a great job. I don't care that all 49 of those failed.
Sure.
That's a much different thing than saying, every single project in your portfolio has to succeed. So that's the kind of ideas I've been thinking about, again, with my economist hat applied to science, to making the portfolio more at the frontier.
Yeah, I was curious about, you have a medical degree, and you're also an economist, and I was wondering the perspective you bring to that, but I think you've just answered that question for me. It's largely incentive based, which, I hear a lot of economists talk about incentives. So thank you for sharing that with me. I would think I'd be remiss not to mention that you were recently named the interim director of the CDC, which,
oh my God,
I can't find an instance of that happening before. So I think that underlines how big of a responsibility it is. I was just kind of curious about how you're approaching leading the two agencies and whether or not you had specific goals for the CDC.
Yeah. So actually, I'm wearing two pins. One is a CDC pin and one is an NIH pin. So just to and it's only recently, like the last week or so, that I was appointed as the acting director of the CDC. There will eventually be, I hope soon, a permanent director of the CDC. The CDC is in a way, it's a sister organization to the NIH. Its mission is public health.
Yeah.
Right. If there's a disease outbreak, we send teams of people to help with the disease outbreaks, and might be send vaccines or treatments, and we surge expertise into anywhere where large disease outbreaks might occur. Right. We support local, state and local public health in the activities they do, including in chronic disease prevention, drug overdose management, a whole host of like sort of practical operational things. They do have a research arm, but it's in support of this public health mission. Whereas NIH is primarily a research organization. You can see those kind of things overlap to some degree. So
definitely,
I much of my research before I became NIH director, I was a professor at Stanford for 25 years. It was on public health topics, as well as on research topics. I don't think it's not possible, I think, to do both of these jobs continuously for years and years. And I've accepted this because I think the CDC is at a critical point where we really need to think about how to reform the organization in ways that address the many public health challenges of the country. It's had some leadership transitions that have been like quite disruptive. And so like, I think for me, I'm viewing this as an opportunity to bring the CDC and the NIH closer so that the research missions of the NIH can help support the decisions that the CDC makes. It's tough because the CDC is located in Atlanta. I just spent the last several days in Atlanta. But at the same time, I've been NIH director now for about a year. And we have a great leadership team here at the NIH. The organization, obviously there's problems that I have to address and solve, and I'm still present to do that. But if you'd asked me to do this a year ago when I just started at the NIH, I would have said, no way, it's not possible. No human can do it. I think given the experience I've had in the last year, especially watching the close collaborations that NIH and CDC scientists already have, I think it's possible to do this. At least I'm going to work very, very hard. I'm not getting a lot of sleep, but that's okay.
Well, if you need help, I could do one of the agencies. It's not the first time a podcaster has taken a role in the federal government, so why not another?
Well, I'm very, very happy to accept help from anyone that can offer it. Thank you.
I am woefully underqualified, but anyway. So I was reading about the priorities you set out for the NIH last August, and one of the things that stuck out to me was your focus on encouraging reproducible studies. Could you tell our audience what replication research is and why we don't see it happening a lot?
Yeah, so this is one of those things where like it's when I tell people about it, they just almost can't believe this is true, but it is true, right? So in 2006, I think it was, a colleague of mine from my old institution, Stanford, named John Ioannidis, wrote a paper with the title why most published biomedical research findings are false. Now, this is one of the most highly cited papers in scientific history. It's it's a very short, simple, easy paper to read. I read it and I was absolutely astonished because before I read it, I thought it was, there's a lot of funny science and it's not true that everything published is true, but I generally thought that if it's published, you're pretty sure you're reading something that might be true.
Mm-hmm.
After I read it, I realized John was right. And the reason is science is difficult. It's hard. And the publication standards we use for deciding what science gets published is peer review.
Mm.
Peer review is important, but it's not the same thing as independent replication. Peer review checks the logical consistency of the arguments in a paper, but I've been a peer reviewer for thousands of papers in my career. Never once was I offered a data set to recheck it myself. I just offered the paper to read and see what ideas I had about it. Since then, there have been a whole number of projects to assess whether the claim that John made in his 2005-2006 paper are actually correct. And so people will go find the top papers in cancer biology, the top papers published in psychology, in neuroscience, and they'll try to do replication where independent teams look at the methods of a paper, try to do the same thing. And distressingly, time after time after time, a large fraction of papers do not find the same answer. It's routine that the replicating team finds lower effect sizes than was claimed in the original paper, for instance.
Right.
And this is in important fields.
Yeah.
And it's likely true for every scientific field. It's because science is hard and the publication standards we have are imperfect. We're human. So the key thing about the replication crisis then is that it exists. And then second, that it matters, right? Doctors have to make decisions, real important decisions about how to give good advice to patients while they rely on the scientific literature. If the scientific literature is not replicable, then there are a lot of scientific ideas that are in the literature that aren't true.
Sure.
There's actually another flip side of this. There's no incentive to publish negative or very little incentive to publish negative results.
Mm.
So a large chunk of the scientific knowledge is not in the scientific literature, all the negative associations. Replication is hard to publish because it's not a new result. Why would a journal want to publish it?
There's no novelty there. Right.
It's this cultural problem in science because anyone who's done science and remembers like grade school science, the first thing you learned is we learn about science by checking each other's work.
Yeah. Replication
is the core basis for truth in science. And yet we've created a sociology of science where it's like undervalued. It's not actually the core for deciding whether things are true or false.
So how do you plan to encourage more of this kind of work?
Well, that's the nice thing about the NIH. It is the 500-pound gorilla in the room in biomedical sciences. As I said, it was like the number one funder. Mm-hmm. So there's a few ways to do this. So first, we're going to start funding researchers to do some of this independent replication. It's very important that this replication, like the ideas that are subject to replication, be chosen by scientists themselves. I don't want the government deciding what things to replicate.
Okay.
And this is really important because what then happens then is that we don't have to replicate everything. We give support to scientists to replicate the most influential, important ideas, right? If the idea is true, science goes one way. If it's false, it goes another way. We replicate those ideas rather than literally everything. And it also turns replication into an honor, right? Right now, if my ideas are subject to replication, often scientists view it as a threat. Oh my God, I'm going to be proven wrong.
Okay.
But they should be thinking differently. If other scientists are interested in your ideas enough to want to actually replicate them, or try to replicate them, that means your scientific ideas are important. It's an honor to be replicated. So one, we'll start funding research for replication. And second, we'll create a journal, a repository where people can put their replication work. And then scientists will start getting credit for doing it. And then finally, we'll link the sort of, people that do search engines, any scientists listening or any students that are listening that do science, they know they can go do a search for scientific papers. That's how you learn science, right? Is by reading scientific papers. For the NIH, we sponsor something called PubMed, where it indexes every single biomedical research journal, almost every single biomedical research journal. And if you search, you'll find the paper. And there are lots of links to other things. We're going to add a replication button. You'll click the replication button, and there'll be an AI summary of all of the relevant replication papers for that paper, along with links so you can check yourself. It'll revolutionize how we think about what's true in science. Instead of saying, oh, is it published in our top journal? Instead, we'll say, oh, goodness, is it replicated as a basis for deciding scientific truth?
You mentioned students there a moment ago, and I had a question about students. Do you have any tips or just advice for students who are getting started in science right now, or maybe want to pursue a career in research or specifically biomedical research?
Well, first of all, those students who are interested in this, I absolutely applaud you. And I also say, like, you are in for the adventure of a lifetime, an intellectual adventure like no other in history. Right? I'm frankly envious because 50 years from now, when I'm long gone, I suspect that we will know so much more about biomedicine and about science, and we'll have addressed so many of the problems that we face today with these new ideas. Students that are listening, you're in for a tremendous adventure, and to be part of it is going to be an honor of a lifetime, I think. So if you're going to go into it, please, absolutely do that. You asked for advice. Let me just give 2 pieces of advice.
Please.
One is work really hard. There's no substitute for that, right? Learn the math, learn the biology, learn the chemistry, whatever your field is. It depends. Learn the psychology. Work really, really hard. That investment you make will and just be curious. Allow that curiosity to guide you in that. Will allow you to link fields together that weren't linked before. It'll allow you to see opportunities in fields and ideas in places that no one has seen it before. A lot of students, they feel like, oh, everything's already been discovered, and I can't possibly find something. I'll just tell you, it is just not true. It's fundamentally not true. The world is there to be discovered. I think there's been so much advance in biological knowledge, but I look at what we know, and I despair in what we don't know. Why do we still have deaths from cancer at such high rates? Why do we still have Alzheimer's disease and don't know how to address it? Why do we have autism at high rates? All of these are subject to that when we do, what we need is new ideas.
Yeah.
New connections between ideas. There's tremendous opportunities in this. It's not true that everything's been discovered. The second piece of advice, be brave. Be brave. If you have an idea and you're a young person and you're having a new scientific idea, I guarantee you the first thing you're going to hear from everyone around you is, oh, that can't be true. That's not right. And, often that's true, but sometimes it's not true. And the only way you can check is to be brave, to say, look, I'm going to try this idea out, even and go see where it leads. Especially if your intuition leads you that way, you have some passion around it. And every single big advance in scientific history started that way, with an idea that everyone says is wrong, and yet when it's pursued to its end, and other people then start to look at it, it turns out to revolutionize the way we do have to do things.
I'm in Arizona. One area of interest for our state is the health of tribal communities and tribal nations. There's 22 federally recognized communities here, and you've said you're committed to strengthening tribally focused research grants. Could you expand a little bit about those efforts?
Absolutely. Right. So first of all, the health needs of tribal communities are tremendous. Right. The chronic disease rates are higher. Rates of mental health, suicidality are higher. Life expectancy is so much shorter, and it's heartbreaking. So the NIH has an absolute obligation to work with tribal communities to use our research portfolio to address those health needs. Right, and I'm committed. I've spent days and days consulting with tribal leaders for how best to do that. The challenge has always been, frankly, lack of trust and earned distrust, where the federal government does things that violate the sovereignty of tribal communities, and especially for the research enterprise, we ask people to volunteer themselves on research projects, and when you don't have that trust, it's very difficult to do.
Yeah.
The thing I've been focused on is investing in first that when you do a research project, with tribal communities, actually with any patient group, we shouldn't be thinking of researchers as like standing above studying. That you do that with petri dishes, but not with people.
Sure.
So it's what I've been encouraging, and we've been funding is research where the researchers collaborate alongside the tribal communities, and the tribal communities lead in telling us what they need, what their needs are, and how the research should be structured. And it's also taking the scientific ideas of the tribal community seriously. Mm-hmm. We still need to do rigorous science, of course, but there's lots and innovative ideas that come out of tribal communities. So really like building those trust relationships so that we can really address the problems of the tribal communities, as well as training scientific leaders to come out of the tribal communities. Both are very, very important, and we're investing in the full range of those because if the research mission of the NIH is to make America healthy, which it is, you can't do that without making American Indian communities healthier.
You visited ASU in January, and this is an ASU podcast, so I need to mention my home institution. And you met with university leaders and researchers. I was curious if you had any takeaways from that visit you'd like to share with the audience.
I mean, ASU is a tremendously important and amazing institution, especially for. Of course, I focused on the scientific, the science labs. I found a tremendous amount of innovation, both in teaching science and also in researching science. ASU gets lots of ASU scientists are funded by the NIH with big advances coming out of ASU. It's a great institution, really truly fantastic institution, both to learn science and to do science.
Thank you for saying that. I've done my job well. I wanted to ask you.
Well, the thing is, like, it's easy to say, like, in a sense, but I specifically picked ASU because I was invited to go there and see, and I actually had worked with ASU scientists in the past when I was still a researcher, so I had some sense of it, but I didn't. When I went, I saw the range of investments that have been made, and the kind of enthusiasm there is for science at ASU, and I just came away tremendously impressed.
So I wanted to ask you a personal question. I heard you're a big board game fan. We have that in common, and I was wondering. So I believe you have 2 grown children, right?
Three grown children.
3 grown children. So I have a 4-year-old daughter, so I'm playing a lot of Candyland and Pretty Princess right now.
Don't worry, it gets better.
Please tell me when it gets better and what games you played with your kids as they were growing up.
Okay, so I have a middle son. He's now 20. I taught him chess at 6.
Okay.
to my great. Then at 8 he beat me, and I've not yet been able to beat him since. There are these Ticket to Ride.
Ticket to Ride's great.
I love Ticket to Ride. Yeah. There's a kid's version of Ticket to Ride, which is absolutely fantastic. And 4 might be a little young, but when your child is 6, 7, they're gonna, and then you'll see it just explodes. Where and for me, I love board games partly because it allowed me to connect with my kids and with my friends, to do something social. I love strategic thinking. Unfortunately, I'm very bad at them. I'm good at explaining the rules. I read the rules and I explain the rules really well. But every board game I ever get, within one game, my kids are better than me at it. And so I just bought new board games, learned the rules, and and then lost to my kids in it. So,
well, you convene people around the table, which is important, right?
Yeah. I'm into these very complex strategy games. They're called Euro games.
Euro games.
Where there's no direct remember the old board games like Risk or something, there's direct conflict.
Okay.
Here they're more you have a set of resources and you're trying to compete with someone else where you're not directly attacking them, but by strategically identifying resources that your opponent needs before you build economic engines. You'll see there's a tremendous amount of innovation that's happened in the last 25 years in board games.
Again, I'm seeing the economist part of your training come through.
But don't expect to beat your kids. That's my one piece of advice on that.
I appreciate that. So I like to end every show with asking my guests if they have some recommended resources for the audience. And I thought it might be fun if you recommended 3 board games for people. One, if someone wants to just kind of dip their toe in the water, the world of board games, an intermediate one, and an advanced one.
Wow. So I have my kids say I have too many board games, which is I'm gonna have to put them have them go to their room for saying such blasphemy. So it's hard to pick among them. All right. So for a beginner board game, Azul. Okay. Azul, Azul. Yep. It is a fantastic. It has the weirdest theme. It's about Portuguese tile laying.
Yeah.
But it's fast and it's fun and it's really easy to learn and. I played it. We play it all the time.
It's really in my rotation too. Yeah.
Portuguese tile laying. Like it's hard to describe the theme, but like as soon as you bring out, it has these like tiles, and you put your hand in the bag and you pull the tiles out. It's it's just there's something tactile about it. It's really fun
and it's very beautiful. Strategic. It's a really pretty game too.
It's very pretty. For a intermediate game, okay, this is really geeky. There's a game called Castles of Burgundy by a man named Steffenfeld.
Okay.
It's the old version of which I have is the ugliest beige-looking board game in the history of beige-looking board games, but it's ridiculously strategically interesting and actually not that hard to learn. But you have to get a little into board games before you play it, but it's worth playing. And then finally, if you're really, really, really deep into the Euro game movement, almost any game by Vital Lacerda. My personal favorite is a game called Vinhos. It's about, again, Portuguese winemaking.
Okay.
But there's all kinds of others that are really, really excellent. On Mars, he has it's these deep, intricately connected systems, and you have to you do something in one system, you invest in one system, but you can't do well unless you do well in the other system. At the same time, your opponents are also investing in these systems, and they have to be. It's a mind blower, but it's really, really fun.
I'll put those recommendations in the show notes. Jay, thank you so much for joining us on the show and sharing your thoughts and perspectives and plans for the NIH.
Thank you for having me. So pleasant talk. So pleasure to talk with you. No one's asked me about board games before, so I gotta say it's a real thrill.
I'm glad I could be the first. ASU will be opening its medical school in the fall, the John Schufelt School of Medicine and Medical Engineering. So we'd love for you to come back and see that in operation.
I'd love that. I had such a good time visiting ASU. So when the med school is open, I'd love to come back.
All right. Thank you so much again, Jay, and have a great rest of your day.
Thank you so much. Thank you for the questions. Thanks for the podcast.
Thank you for tuning in. If you enjoyed the show, please leave us a 5-star review in the podcast app of your choice. If you found us on YouTube, we'd really appreciate a like and a subscribe. Lab Coat Optional is a joint production of all the talented people at the Strategic Marketing and Communications team at Knowledge Enterprise at Arizona State University. Knowledge Enterprise is led by Executive Vice President Sally C. Morton. Until next time, stay curious.